Calculus examples. The quotient rule. This is video 9. An introduction to the two quotient rule formulae. A. y-x equals gx times f-x minus fx times g-x divided by gx all squared, and b. y-x equals gx times d dx of fx minus fx times d dx of gx divided by gx all squared. The following list of 5 short videos shows all videos, including this one, that involve the quotient rule to find the derivative of a function in an example or an application. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. Reminder: d dx, the differentiation operator. The symbol d dx is called the differentiation operator because it tells you to differentiate the function of x to its right. The following examples illustrate this important fact. 1. d dx of a function of x means differentiate the function of x inside the brackets with respect to x. 2. d dt of a function of t means differentiate the function of t inside the brackets with respect to t. 3. d dr of a function of r means differentiate the function of r inside the brackets with respect to r. In most textbooks, the function to the right of the differentiation operator is in brackets. A table of derivatives with examples that use the symbol d dx is in a video on my channel. A common error when using the symbol d dx. The symbol d dx must never be in an equation without a function of x to its right. This is illustrated in the following equation. d dx is followed by a function of x, correct. d dx is followed by a function of x, correct. d dx is not followed by a function of x, wrong, because d dx is not followed by a function of x. The quotient rule. Some equations have an equation number to their right, so the equation can be referenced later in this video. Let the function y be defined as y equals fx divided by gx. Then y is the quotient of the two separate functions fx and gx. Now pre-multiply both sides of the above equation by d dx, giving d dx of y equals d dx of fx divided by gx. Then the quotient rule can be written in the form dy by dx equals gx times d dx of fx minus fx times d dx of gx divided by gx all squared. Call this equation equation 1. And since dy by dx equals y dash x, equation 1 can be written as y dash x equals, call this equation equation 2. There are 4 separate functions on the right-hand side of the above equation. Gx, d dx of fx, fx, and d dx of gx, where d dx of fx is the derivative of fx and d dx of gx is the derivative of gx. From equation 2 on the previous screen, the quotient rule is, call this equation equation 3. Since d dx of fx equals f dash x, replace d dx of fx in equation 3 above with f dash x, and since d dx of gx equals g dash x, replace d dx of gx in equation 3 above with g dash x. Equation 3 is now formula A on the first screen of this video. When you first start learning the differentiation rules, you may find it easier to find the derivative using formula A, which is equation 3 above. However, formula B is the most important because it uses the differentiation operator d dx, which will be in many topics later in your course. Once you have obtained the derivative, you must simplify it. Video 10 uses the quotient rule formula A, while video 11 and video 12 use the quotient rule formula B. How to simplify the derivative is fully explained in all three videos. Do not forget that once you have found the derivative, you must simplify it.